So the warm-up today is plotting points, and those of you who weren't here yesterday, before we start that, look at all these cool things that people have done with polar graphs. Polar graphing is with circles. Okay. Okay. So yesterday, review. Somebody who was here yesterday, explain how to plot the point. Let's start with degrees. 4 and 90. Okay, so this is a positive, so we're rotating from what's called the polar axis or the positive x-axis around to 90 counterclockwise. Yes, and these are radius of 1, 2, 3, 4. These are even labeled, so we go out to this radius of 4, and we put a dot there. This polar graphing is used in, like, radar uses this when you see a ship or a plane on radar or air traffic controllers. All right, what about 2, negative 135? Chadwick, can you explain that? Oh, got a mouthful of gum.
No, so you go backwards down.
Yeah.
Down
Okay, so 135 isn't on here, but if you look at your unit circle, which you will have, it falls between here and here. So it's rotate 90 plus 1, 2, 3 more marks. But a negative means we're going negative 90 plus 1, 2, 3 more marks. So this would be negative 135, otherwise known as 225. And then it says go out 2, so we go 1, 2. All right. Now, what about negative 360? Gets a little more complicated. Kelsey? Okay. Yes. So this means, okay, so like I'm standing at the origin, I'm now facing 60 degrees, but this negative means I'm backing up 1, 2, 3 on what's called the opposite ray. In other words, basically you're adding 180, okay? So this point over here is negative 360. All right, before I do a negative, what's a better name for that point? Because every point here has multiple names. Kelsey? Yeah, we could have called that same point 3, 240. Does that make sense, guys? All right. Negative finally would be, let's see, negative 5, negative 300. Where would that one be? So negative 300 is all the way around to positive 60. Oh, I didn't do this very well. Now I got to back up 5. So 1, 2, 3, 4, 5, it would be out here. That's that one. Yes, which could have been called 5, 240, or negative 65, etc. Multiple names. Do you need me to go over it in radians? It's the same things. Anybody want to see more explanation? Anybody who has gone? Okay. So we're going to try graphing a graph. This has been, the graph is 1 plus 2 sine theta. We'll work on the calculator in a second, but for now, someone typed all these values in radians, okay, into the calculator and got these decimals. So we're going to plot 0 degrees of rotation and out 1. I need everybody with me here. 0 degrees of rotation and out 1 is right here. Check. Okay, pi over 6. So we go to this line right here at pi over 6, and it says go out 2. So you're at this point. We good? Go to pi over 4, which would be this one in between here, and go out to 2.4, which is like almost in the middle of 2 and 3. Then it says go up to pi over 3 and go out 2.7, so you're almost to 3. Then go to 90 and go all the way out to 3. Pi over 2, 3. Now, this is a curve, if you notice, okay, just so we're keen on what we're doing here. All right, now we're to 2 pi over 3. We're back down to 2.7. 3 pi over 4, which would be this line, we're at 2.4. 5 pi over 6, which is this line, we're back to 2. And at pi, we're at 1. All right, so far, what we have kind of looks like a circle. Everybody good? All right, now we're at 7 pi over 6, 0. 7 pi over 6, oh, we're back at the origin. Okay, that's this one here. Now, gets a little tricky. 5 pi over 4 would be here. We need to be at 0. No, we're negative. Okay, sorry, I was at the wrong spot, right here. We're going to back up 0.4, so somewhere in here. Instead of going out towards 5 pi over 4, we're backing up. But we continue to rotate around the circle. That's why the numbers are getting bigger here. 4 pi over 3 is this line, and we're backing up 7, so almost to 1. I don't know. These are so close together, I can't really. And then at 3 pi over 2, we're at negative 1, which would be right here. So this is the curve we just did. We continued around to there. All right, now 5 pi over 3 is this line. We're backing at 0.7, so we're here. 7 pi over 4 would be this line. We're backing up, and we're a little bit closer to the origin at 0.4. 11 pi over 6, we're back to 0. So we have a loop inside of there. And then at 2 pi, we're back at 1. This is what it should look like. I don't know if yours turned out very well or not. This is one of many. I would not want to have to do these by hand because there are hundreds of different graphs you can get. Okay? This particular one is called a limousin. It's a French word, and I don't know if I'm saying it right. I always call it a lima bean because it looks like the inside of a lima bean to me. Or here, I show you, it looks like the inside of an apple, right? Cut open. But the word reminds me of lima bean, so that's how I think of it. Okay. Ready to try the calculator? So your calculator needs to be in polar and radians. Okay, polar mode. Whoa, that popped up before I could. Yes.
Degrees.
For the graphing you're going to do, you're going to always be in radians. The degree problems are just plotting points, and so those aren't going to be on the calculator. So when I ask you to graph something in polar, you're generally going to be in radians. This is a quiz where you have to switch back and forth between degrees and radians several times. So we're going to talk about that on Friday or Tuesday as we get ready for Wednesday's quiz. No. Yeah. All right. So polar down here and radians here. Everybody good? All right, go to y equals, and you should have some crazy business with r's there now, yes? All right, this question says type in 2 cosine 2 theta, 2 cosine 2, and theta is now this button. Remember, x was in function mode, t was in parametric mode. Now we are in polar, so this button right here will give us a theta. Oh, nice, I got nothing. Okay, hang on. What was it supposed to be? 2 cosine 2 theta? Was that what? Did I get it right? Okay, thanks. All right. So if you do this, it'll work. If you do a zoom square, no, do a zoom standard first. My bad. Do a zoom 6, and then if you do a zoom square, it'll square it up. Yes. Anybody not getting it? Okay. So this one, 2 cosine 2 theta, gave us 4 petals whose length was 2. Can you tell on there, guys, that it goes out to 2? I want to show you this, but don't do this, okay? You can trace, right now mine is giving me an X and a Y. I can go to the format and turn it on to polar up here at the top. And then when I went back to trace, it would give me the R and the theta, and it says it's out at 2 here at 0. If I traced around to pi, so roughly 3.14 right there, it's back at 2. But if you put it in this mode, no one's going to remember how to get your X, Y back. So I would just leave it in rectangular because there's no reason to have an R theta. I'm not going to make you draw super accurate ones on the quiz. Everybody good? Okay, let me talk more about this. It's called a rose. The furthest points are 2 units from the pole, and it had 4 petals. We're going to do this one, 2 sine theta. Go kind of quick here because, whoops, some of you want to do a retake today, right? 2 sine theta, was that all it was? Okay. It's actually a circle. Okay. Notice the symmetry. Did it go up to 2, guys? So it was a circle here. It has y-axis symmetry, and it had the word sine in it. Okay, that's going to be important. Which, by the way, what is the name of that line? Does anybody remember from yesterday? You still need to watch the video if you weren't here yesterday, because there's other things besides plotting points that we learned. The line is theta equals pi over 2. That's one name for that line of symmetry. All right, number 2, 2 plus 2 sine theta. Okay. This is called a cardioid. It's like a heart. It's not very pointy, but that's the word I think of when I see these. Okay. It crosses at -2, +2 on the X, Y, and then up here it goes 1, 2, 3, 4 up. So if we were trying to draw this accurately, it would go like this. And then it would go up to 1, 2, 3, 4 up here. Oh my goodness. That was horrible. Just skip that line right there. So something like that. All right, anybody have worksheet 10 out? By the way, this had a sign again, and it was symmetric here with the Y, folded over across the Y again, right? All right, we're going to look at worksheet 10 in a second, but right now do one more of these by hand, or on the calculator, my bad. 1 minus 3 cosine theta. Okay, what is this called again? Does anybody remember? Can anybody say it? How's that? What is the shape called? Do you remember? Yeah, Limason, whatever this thing is called. Whoa. Yep, nope. Something like that. How did I do? Does that look right for the calculator? Did it go out to 2 and then 4? Okay. What kind of symmetry does this one have? It does not have y-axis, or it has this symmetry, right? There's where we could fold it in half. So that is the line theta equals 0 or theta equals pi. Okay, it's called polar axis symmetry, I believe. I am not going to ask you a question about symmetry on a quiz. All right. Please stick with me for just a second here, and then we'll let you go crazy on the calculator. So y-axis symmetry is called theta equals pi over 2 symmetry. X-axis symmetry is called polar axis symmetry. Origin symmetry is called to the pole, because the origin is called the pole. I am not going to quiz you on this. There are tests that prove this, and many, many things will have more than one kind of symmetry. Okay, this is worksheet 10. Everybody got our worksheet 10? I want you to just look through these. It says if you graph something like r equals 2 cosine theta, you're going to get this shape. Because it's cosine, it has x-axis or polar axis symmetry. Everybody see that? If you put like r equals, we could even make it negative 2 sine theta, it will be down here, but it will have x-axis, which is also called theta equals pi over 2 symmetry. Those were circles. These are the lima beans or limacons, okay? There are different kinds. The inner loop, the one that's called cardioid, which doesn't have the loop, it just looks like a heart kind of. It can have what's called a dimpled limacon, or it doesn't even have to have hardly, it's just a weirdly flat thing. Anybody know what has this shape? Anybody been to the Bean at Millennial Park? It's a three-dimensional polar graphing thing, yes. Okay, moving on. These that have sine here, okay, or cosine. Cosine is x-axis symmetry, sine is y-axis symmetry. All right, the more fun ones, roses. Notice up here, it says if a rose has n petals and n is odd, okay, it'll have 2 n petals if n is even. So if you put in a 2, it has 4 petals, but if you put in a 3, it just has 3 petals. If you put in a 4, it has 8 petals. If you put in a 5, it has 5 petals. Odd number is the number of petals. If you put in an even number, it's twice as many for the n value. And again, sine makes it have y symmetry. Cosine makes it have x-axis symmetry. But you will notice some of these have both x and y. All right. And then there's a spiral. When you do this, all you put in is r equals like 0.1 theta. The 0.1 makes it smaller, so you'll see that. Let me graph one for you. These are kind of fun. We were doing this yesterday in one of the classes. If I just graph 0.1 theta. Oh, okay. Doesn't get very far. If I made this go further, here you go. Okay. Notice when it was just to 2 pi, when this was just 6.28, it didn't even make it around once. Okay. But if you made this number bigger, it will keep graphing and just going out further and further and further and further. Okay. Most of the time you just want to leave that 6.28 because otherwise your calculator will freeze up and you'll not get done. All right. Did we miss any? Is there one more? No? That's all of them? Okay. We talked about symmetry, or I did, on 1 through 3 already. There's some more of these we're supposed to graph. Can you do these on your own in a minute? I don't want to take up time. I want people to be able to do the retake. But I do want to revisit. These are just sketching graphs. Okay. Number 6, 3 cosine 2 theta. If I graph 3 cosine 2 theta, which was like this, whose petals are 4 units long, 3 units long, that's what that front number tells you, how long the petals are. This meant there were 4 of them because it was even. So that was this one, 3 units long, 4 of them. Okay, so what is that called, guys? Which of these words? It's Sister Rose. Okay, number 7, I want to talk about this question. Please tell me some polar coordinates for that question right there. Okay, 3, 330. Does that meet the requirement? They said you have to give me a number between 0 and 180. 150, 3. -3, 150. And I love that Kayvon said 150, -3. You weren't here yesterday, but if Hofbauer were queen of math, we would write them in the other order because that's the way I think of them. You rotate and then you go forward. So, but that's not the way the real world works. I don't get to make things up. So 3, 150 is around to here and out 3. And -2, 45 is out to 45 and back up 2. Now, they want to know the angle in between these two dots. No, actually they don't. They want to know, we need the angle, but they want to know the distance between them. Okay? If you weren't here yesterday, guys, take out your pink sheet real quick. At the bottom of the side that does not have the unit circle on it, there is a formula for finding distance. That formula looks like this. It is the square root of each length minus 2 times the square root of each length again, times the cosine of, and the angle in between these. Now, does anybody recognize what that really is? It's law of cosines, okay? This is 2, this is 3. Now notice if you use law of cosines, you don't want negative numbers in it. And the distance between here is actually, this is 225 and 150. The distance in between there would be 30 and 45, 75, which is the same thing you're going to do down here, okay? And then I'd have to remember to square root at the end. So this is the law of cosines. This is the formula on your sheet. But I'm guessing you all got the wrong answer. Does anybody know why? Because I did it wrong 6 times yesterday. This has to be in degrees because these angles were in degrees. So yeah, Kelsey figured out right away that I was doing it wrong and she just watched me do it wrong for 5 minutes. No, it's fine, honey. You're fine. Okay, so square root of, help me remember what the numbers were, 3 and -2? Or was it +3 and -2? Somebody? Plus -2 squared minus 2 times 3 times -2 times the cosine of, what was it? 50 minus 45, 30, -45 minus 45. Okay, so this is the formula that's on your sheet, okay? If I had used law of cosines, what did I say, 75? What did I do wrong? I'm still in radians. That's what's wrong. I can, yes. Okay. Once again, I'm a fail. Did not put my calculator in degrees. Okay, so those of you who did, no doubt got a different answer than me. Okay, if I go up and do this one in degrees, I get 3.14. If I do this one in degrees, I get this because then I still need to square root. They should be the same answer, 3.14, yes? Okay, so we should have got 3.14 because we should have been in degrees. That's the distance between those two. Okay. Number 9 is just a graph. I'll let you do that. Number 10, can anybody figure this out? She wants petals that are 8 units long. Nope, just kidding. 8 petals. Anybody know what that would make the n value? Yes, you only need 4. And the petals are 4 units long, so there'd be a 4 out front. Does it say where she wants? Doesn't say what kind of symmetry, so you could do cosine or sine, I think. See if those make a rose for her that has 8 petals, 4 units long. Somebody check in? Does that work? Do they both work? Yes? Okay. All right, either one of those would have worked for her. All right. I'm not going to ask you that question on a quiz, by the way. Here's the homework assignment. It is on 7B are the problems, and on 7A there's graph paper for you to put the answers. Okay. It says down here when you're all done, put your calculator back in function mode, but I don't know that it really matters. I don't have a class that needs it. All right.